Hi, my name is Jamie Hardin, and thank you for tuning into my video about database. So first, let's get started here and talk about what exactly is a database. So a database is an organized collection of data. It is a collection of schemas, tables, queries, reports, views, and other objects. The data are typically organized to model aspects of reality in a way that supports processes requiring information such as modeling. The availability of rooms in a hotel is a way that supports finding a hotel with vacancies. Databases are also used to support internal operations of organizations and used to underpin online interactions with customers and suppliers. Databases are also used to hold administrative information and more specialized data, such as engineering data or economic models. Another important facet of a database is a database management system, or DBMS. It is a computer software applications that interact with the users, other applications in the database itself to capture and analyze data. The DBMS serves as the intermediate between the user and the database. The database structure itself is stored as a collection of files, so we can access the data in those files through the DBMS. The DBMS receives all those application requests and translate them into complex operations required to fulfill those necessary requests. A database is actually not generally portable across different DBMs, but different DBMs can operate by using standards such as SQL and JDBC. So next, I'd like to talk about the difference between general purpose DBMS and also specialized data based management systems. So database management systems has evolved into a complex software system, and its development typically requires thousands of human years of development effort. Some general purpose database management systems, such as Adabas and Oracle, have been undergoing upgrades since like the 1970s. General purpose database management systems aim to meet the needs of as many applications as possible, which then adds to their complexity. However, because their development costs can be spread over a large number of users, many of them are often seen as the most cost effective approaches. A common example of a special purpose database management system is one that performs many functions of a general purpose database system, such as the insertion and deletion of messages composed of various items or data or associating messages with a particular email address. But these functions are not limited to what it was required to handle email and don't provide users with all the functionality that will be available using a general purpose email system. So some of the ways that databases are used are in research. For instance, data technology has been active as a research topic since the 1960s, both in academic and also engineering and things like that, and development groups for companies. For example, IBM research. Research activity includes theory and development of prototypes, and some notable research topics have included models, the atomic transaction concept, also related to concurrency control techniques and creating of language and other things like that. So how can databases can be used in design? So the first task of a database designer is to produce a conceptual data model that reflects the structure of the information to be held in the database. A successful data model will accurately reflect the possible state of the external world being modeled. For example, if people have more than one phone number, it will allow this information to be captured. Producing the conceptual data models sometimes involve input from business processes or the analysis of workflow in the organization. So some of the huge advantages of switching to a database is that the improved data sharing. It allows one of the biggest benefits is that it allows users to have better access to more and better managed data. This improved access then enables users to respond much more quickly to changes to their environment. So if something happens to a company, they're able to respond more quickly because they're able to access the information much more quickly as well. With more users accessing data, there's also a greater risk of breaches, but we also get a greater improved data consistency because we have so many users. So as I said earlier, some of the disadvantages can be with so many users, there is a greater risk of running security breaches. Also, these systems are very complex, so they do oftentimes require a greater cost. One of them being because the systems have to be maintained, and well as software has to be updated quite frequently to make sure that these systems are reacting and also working correctly, this can cost not only a lot in terms of infrastructure, but also in terms of the people that have to actually physically update these applications as well. So, some well-known databases that we have, as you can see on the slide here, are Oracle, the Microsoft SQL Server, IBM DQ, the SAP Sybase ASE, and Amazon Simple's database. So, the first one that I'd like to talk about is actually Oracle. So, Oracle was the first commercially available relational database management system. Oracle's name is synonymous with enterprise database system. It also has a well-known reputation for being an unbreakable data delivery and also fierce corporate competition. The current release of Oracle's relational database management system is Oracle's 12c. It's reflective of Oracle's work in extending its enterprise relational database management systems to enable firms to consolidate and manage databases as a cloud service when needed. Next is Microsoft's SQL Server. It is an extremely popular operating desktop system. If you're running on any Microsoft Windows based server, more than likely you're using the SQL Server on it as well. SQL Server's ease of use, availability, and tight Windows operating system integration makes it an easy choice for firms that choose Microsoft products for their enterprises. Microsoft also promotes the latest release of SQL Server as both the platform for premises and cloud databases and business intelligence solutions. Next, we have IBM D2, which is considered to be one of the big data centers. IBM D2 contain database service products produced by, of course, IBM. These products are all support the relational model, but in recent years, some products have been extended to support object relational features in non-relational structures such as JSON and XML. Also, IBM has been able to create the Watson computer system, which has been famously seen as winning a Jeopardy against some of the world's most famous geniuses. This computer system is able to answer extremely tough questions in a matter of seconds. So thank you for tuning into my video about databases. As you can see, this material is very complex, but if companies are able to reel in this information, this vast majority of information, they are able to create a very, very big advantage for their company because consumers are then able to use this information much more frequently and also much more easily as well.